Hi there, everybody. In this video, we are going to start to introduce trigonometry. So trigonometry is just the study of triangles, where we're going to look at their sides, angles, and then in future courses, you're going to look at more with the triangle. But for the purposes of this course, we're going to be looking at the sides and the angles. So the first thing we're going to do is right triangle trigonometry. We're going to look at how trig works when I'm dealing solely with right triangles. So when I'm doing right triangles, we have these ratios, sine, cosine, and tangent. Okay? Sine of theta, cosine of theta, tangent of theta. And it's going to be a relationship of the sides with respect to that angle. So theta here represents the angle in question. So sine, cosine, and tangent are all functions that you'll deal with in future courses a little bit more in depth, but they're an idea that when I plug in an angle into sine, cosine, or tangent, I get out a ratio of the sides. Remember, a ratio of the sides is just something over something else. So we use SOHCAHTOA, that's kind of a mnemonic device, something to help you remember these ratios. Sine of theta is going to be the opposite over the hypotenuse. So opposite over the hypotenuse. So that's why it's called SO, because it's opposite over hypotenuse. Sine is opposite over hypotenuse. So what that means is once you identify, like I got a diagram here, once you identify your theta, sine of theta is going to be this opposite side length over the hypotenuse. Now remember, the hypotenuse is always going to be across or opposite of the 90-degree angle. Okay, let's talk about the next trig ratio, which is cosine of theta. Cosine of theta is going to be adjacent over hypotenuse. Now adjacent is going to be the side length that's touching the angle. So cosine of theta is going to be this adjacent side length over the hypotenuse. Now, you may be saying, but the adjacent and the hypotenuse both meet at that angle. They both touch that angle theta. The hypotenuse is special. The hypotenuse is always going to be opposite the 90. So the adjacent is going to be the leg of the right triangle that touches the angle. That's right next to it. All right, so that's sine and cosine. Next up is tangent. So tangent of theta is going to be opposite over adjacent. So this one doesn't deal with the hypotenuse. I identify, like I'm going to use this theta here, the opposite over the adjacent. The opposite is the side that doesn't touch it, and the adjacent is the leg that does touch it. That's right next to it. Okay, so we use sine, cosine, and tangent in order to solve for missing sides and angles. But for the purposes of this video, we're just going to focus on setting up those trig ratios using SOHCAHTOA. So sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. And tangent is opposite over adjacent. So that's what SOHCAHTOA, that's how you can use this mnemonic device to help you. Okay, now you may recognize in your calculator, and we'll get to calculator in the next video, but you don't see these full spelled out words, sine, cosine, and tangent. You see sin. Okay, don't say sin, that's not what it is, it's cosine. Don't say sin, it's sine. Working ahead of my brain's working ahead. For cosine, you're going to see cos. That's not cos, it's cosine. And for tangent, you're going to get tan. It's not tan, it's tangent. Okay? So that's what you might recognize in your calculator. Now let's work at just identifying these ratios. So in example 1, we want to find the sine of C. Sine of C. So C is acting as our theta. So sine of C equals opposite, the opposite is 20, over the hypotenuse, which is 29. So sine of C is 20 over 29. For the purposes of right now, that's what we're going to stop with. Just setting up the trig ratio, understanding SOHCAHTOA. Okay, so next up we want to do sine of B. So if B is our theta, sine of B, I plug the angle into the trig function, so sine of B equals opposite 21 over hypotenuse 29. So sine of B, the sine of that angle is 21 over 29. So that's the sine function. If you remember, sine is opposite over hypotenuse, SOH. Cosine, cosine is adjacent over hypotenuse. So cosine of S equals, so cosine of S, this is our theta. Adjacent to that is the 45. The hypotenuse is 53. So you'll see there, sometimes I label the side lengths with respect to that angle because that's going to help us set up these ratios quickly. The 45 is the adjacent, the 28 is the opposite, and the 53 is the hypotenuse if S is my theta. That's going to change. That's going to change if R becomes my theta. So cosine of R, this is my theta. 45 is now the opposite, 28 is the adjacent, 53 is still the hypotenuse. So cosine of R, adjacent, which is 28, over hypotenuse, which is 53. Okay? And then we get, tangent. Tangent is opposite over adjacent. That's my TOA of SOHCAHTOA. So if I want to find tangent of S, so if S is my theta, I'm just going to label the side lengths. 60 is the opposite, 25 is the adjacent, 65 is the hypotenuse. So tangent of S is going to be opposite, which is 60, over adjacent, which is 25. So 60 over 25. And then let's find the tangent of R. So if this is my theta, that means that 25 is my opposite, 60 is my adjacent, and my hypotenuse is still 65. So tangent of R is going to be 25 over 60, opposite over adjacent. Okay? So as you start working through trig, maybe you'll notice that these are reciprocals of each other. There are going to be some patterns that you start to recognize as you deal more with SOHCAHTOA and setting up these ratios. So some of those patterns you may be able to see when you're dealing them all in the same triangle. So the try nows that I want you guys to knock out for this video, excuse me, is just to identify all the trig ratios based off of this right triangle, this 3, 4, 5 right triangle. Okay? So that's going to wrap it up for this video. Make sure you pay attention to the next one when we start to use sine, cosine, and tangent to solve for missing side lengths.